rusting. Now try going down.
Middle one makes you go speed up now. There. So in this video, I'm going to quickly describe my project. I have a Zhao SAMD21 here, and I'm using it with this expansion board. It wasn't necessary, but it allows me the ability to add additional actuators later, so I like getting it set up this way to begin with. And I'm using it for the USB capabilities of the microcontroller. And in this case, I have taken this foot pedal I purchased from AliExpress, and I've gone and opened it up to see how the circuit worked. And in the original design, it controls the 3 by using, I believe at least, and I tested it and it works this way, so I assume this is exactly how the microcontroller worked, but it uses a round-robin approach of powering each of the signal wires one at a time while reading the state of the others. And it uses a diode in reverse biased state to send the electricity through that as the power. So it's kind of a weird hacky setup, but they had an additional pin, so what I've done in this case is used a wire with 5 wires inside of it to connect both the voltage, ground, and 3 signal pins without having to do any of that crazy round-robin stuff. But in the end, it works really well. I'm able to get a signal, and I think it actually would work better than the original software here because it had to use that round-robin approach, so at one given time it wasn't checking one of the states of the foot. You might get around that by just tracking the last state it was at, continuing it if it was previously enabled. Project, I'm planning on taking this foot pedal that I picked up on AliExpress and switching it to be Zhao SAMD21 powered. So hopefully it works out well. I'm gonna have to unscrew it, I guess, via these 3 larger screws here. We'll see. I went ahead and removed the screws that were holding in place the pedals, and each pedal has a spring that it uses to push down here and go with a single piece into this line breaking location that the circuit board has that breaks the IR emitter and receiver here. And it looks like each of these colored wires corresponds with a different signal wire, and the black is the common ground. So it makes for a very, very simple project to switch out. In fact, I didn't even need to open these up at all. I can just cut off the top of this USB here and then just use each of those wires as the input. So that's what I'll go ahead and do here. Some investigation, and actually the way this is structured, is, at least I believe this is the way it works, is each of these pins connects to the output of the IR receiver, but they also are in turn used in a round-robin sort of way to power them. So what happens is it'll power, like, let's say this middle board here via the green cable, and go through the Zener diode to power the line here, and it also powers across both power lines. So at one time, one of the given pins is being used to power the other ones. I can get around that, I think, by just soldering, well, I know I can, by soldering a wire from this pin, but it means I can't reuse this whole cabling, so I'll have to 3D print a replacement piece for this. So for this point in the project, I have the piece I've removed from inside of the body of the foot pedal, and I'm going to 3D print a similar piece here to this to lock in place. But I'm going to be using this 5-wire I picked up from Amazon instead of the 4-wire one. And that should allow me to connect to the voltage and thereby using it to get the state of the foot pedals without having to do that weird round-robin thing that I had to do in the with the old setup. I'm a fan of this particular tool because it makes it super easy to remove the shell of one of these without hurting the inner wires. And then I'll be able to do the same for the inner wires. That I've crimped all 5 wires, so now I should be able to stick these through a 3D printed piece for this, and then hopefully everything will just be great. I went ahead and removed the other end of the cable here and cut it down to size, so it's about the same size as the original cable, and now with the 5 here. I'm going to now solder this to the control board, and I'll be looking to also print out that 3D printed piece, so I'm going to have to design and print that out next. Point, I removed the wires here, and I pre-tinned the new wires. That said, I have the new piece installed here. I ended up going with a design that includes a zip tie here to help hold the cable in place. I originally wanted to go with a cable gland, but I couldn't get it to fit in with the piece that comes down on top. And I've screwed in this side over here to keep it in place. The other side gets pushed down into it as well, so it's not going to go anywhere. And as you can see from me pulling the cable, it's not moving either. Yeah. So it should work well. I'll give it a shot now with my code to confirm that everything's working. One thing I noticed is if you loosen it, you get a little bit more motion for this because it doesn't come down as hard, which is nice. So something to configure if you have one of these is screwing it a little less on this to give it a little bit more spring action. Now I'll try it out with the code. So now I'm in the game and I just want to show it with my feet present here in the side screen of it controlling it, one-to-one mapping of the videos. I've got my throttle going and I'm going to lower that so I don't use all my booster on my starter vehicle. And I'm just going to try to get to this Rust City. I think I have to press E in the game, yeah, as a dock. So, just a neat little demonstration. Thank you for watching my video, and subscribe and like the video for more content like this.